I'm Chemical Kim, and I'm here to share with you a product from Education Innovations called Density Cubes. With this product, I'm going to also share with you a density lesson and encourage you to try activities with exploring densities in your cubes. When you receive your cubes, what you're going to discover is that you actually received some of the chemical elements, which is a very exciting thing to have right in your hands. What do I mean by that? Well, if you look at your periodic table and you look at your density cube set, you're going to see right away this beautiful, beautiful metal that we all know as copper, and that is a chemical element. You'll also find in your cube set iron, which is a beautiful metal. It's metallic, like other metals as well. And then you'll have zinc and lead. Now these look very similar. And in fact, also aluminum, I just can't tell you how excited I am to look at these chemical elements, but looking at the difference, you can identify them by how heavy they are. So lead being a very heavy element, so we're gonna put that there. Aluminum being the lightest there in your set, and then your zinc. Now I did leave one out. This beautiful, beautiful metal, look at it, so beautiful, it looks like gold, but it actually is called brass, and it's a metal alloy of, guess which two elements? Well, if you guessed copper and zinc, you are correct. Melting these two metals down, you can form this beautiful metal alloy known as brass, and that's also in your set. My first encouragement before we do the density lesson is to take your metal cubes and put them lightest to heaviest, feeling them without looking at it, at putting them on a balance, and feeling which ones are the lightest and which ones are the heaviest. So let's talk about what density is. By calculation, we say density is the mass divided by volume. What is that indicating in terms of looking at material? Well, first of all, it's a physical property. And second, it basically means how much stuff you have in a specific size space, where volume is the measurement of space and mass is sort of the heaviness of your stuff. Let's look at a comparison. And in regards to our cubes and our elements, and the elements being made up of atoms, let's look at atoms that have, say, a small atomic radius and atoms that have a large atomic radius. Now, it doesn't necessarily mean that the small atomic radius atoms are going to be lighter. They could actually be heavier compared to the large atomic radius atoms. So if we have lighter atoms, but actually taking the same volume as heavier atoms taking the same volume, we would say that this has a higher density compared to this. And we can actually do that calculation and that determination right in your home or your lab if you made your lab in your home. So let's take a look at how that is achieved. So you remember the two parts of density? We have mass and we have volume. So what I'm showing here is how to take a mass. Now I'm using a wooden cube because I am going to leave the mass determination of the metal cubes to you. But I want to show you, when you do a mass, it's not putting it on a scale, it's actually putting it on a balance. And with a balance, you're actually doing a comparative mass to what we have as a standard kilogram. So when you put the object on the balance, these weights move until you have that comparative weight, and once you get your balance to rest, you do the reading. On this balance, I'm recording this as 13.4, but it's slightly past the 0.4 mark, so that would be my guess measurement. So I'll say 13.41. We're going to use that later, and the units on this is grams, and that's going to go into our density calculation. Now that we've determined the mass of our object, let's look at the volume. Again, I'm going to use a wooden cube because I'm going to let you try with the metal cubes. With volume of a cube, one approach that we can take is do volume by geometric measurement. The equation that we'll be using is volume is equal to length times width times height. So I'm going to measure the length, the width, and the height of this cube. So setting up my centimeter side of the ruler to keep it in the metric system, I see that I have 2.9 for the length, 2.9 for the height, and 2.9 for the width. Being that that's a symmetric cube, and putting that into the calculation, volume is going to equal 2.9 centimeters times 2.90 centimeters times 2.90 centimeters. And I carried it to the 100th place value to keep the precision of my instrument. When I calculate 2.90 times 2.90 times 2.90, I get a volume of 24.4 centimeters cubed, and I'm going to use that number later when I calculate the density of this wooden cube. So now comes the fun part. This is where we actually get to figure out the density of our cube, and I'm going to show you with the wooden cube from the data that I collected. If you remember, density, mass divided by volume, the mass of the wooden cube that I determined was 13.41, and that is in the unit gram, so that's the mass that I have for my wooden cube. I'm going to divide that by the volume, which I multiplied by geometric measurement, and that was a derived value of 24.4 centimeters cubed. When I take 13.41, divide that by 24.4, I'm going to record that as 0.550 grams per centimeters cubed. That's really low. Why do I say that's really low? Well, in comparison to the density of water, and that's why I have a beaker of water right here, the density of water is 1. This is 0.550 based on my calculation. So when I put this wooden cube into water, do you think it'll sink or will it float? Will the density be great enough that it will sink down to the bottom if the density of water is 1? Let's take a look. It floats, so that shows that low density. What do you think you'll find with the density cubes? Will they have a higher density or a lower density than water? I'm really excited for you to find out, calculate its mass, calculate its volume, and then do the water test and see if it sinks or it floats, and is your value higher or lower than 1? I'm very excited to share this demonstration with you to show you a concept of density in which temperature can affect density. As we saw with the wooden cube and it floating in the water, water does have a density at room temperature of about 1. But what happens when you have cold water and what happens when you have warm water? So this demonstration really shows that. What I'm going to do first is add some food coloring. The blue is going into the water that is cold, and the red is going to go into the water that is warm. Beautiful as the food coloring falls, so beautiful. Next, what I'm going to do is mix up partners. So I'm going to have this blue, and I'm going to put it on top of the red, and then I'm going to take this red and put it on top of the blue. And what I'd like for you to do is guess what will happen in terms of density. Will the warm water fall down to the cold water, and will there be a flip? Or will the cold water want to flip and be on the top because it has a lower density? So let's take a look. I'll first invert the warm water on top of the cold water, and carefully, it gets a little messy, but carefully we will see once these two meet, does the warm water want to stay on the cold water? Now I'm going to flip the cold water on top of the warm water. Ooh, that was a little messy. But that's okay, it still worked. Still worked. And what are we seeing? Right away, we clearly see that the warm water stays on top of the cold water, so there's no flip. The warm water has a lower density than the cold water. Where here, the cold water has a higher density, so it wants to go down at the bottom, and the warm water has a lower density. So there's a flip taking place. Very cool demonstration to show how temperature affects the density.